Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and today we're going to look at a little bit more details on the Resonance kit, and we're going to look at the big coil today. Now, some of these things I normally only do during my conventions, but I'm going to just show you some things here. We'll see where it goes. So what we're going to do is start off by looking at the resonance coil. Now, for those of you who don't know, we have a kit, and it includes excuse me, two of these coils and some capacitors, LEDs, and a variable capacitor, and LEDs, a frequency generator. And this is going to teach you about resonance. And most people who are interested in free energy don't really understand resonance experimentally. They hear of the term and they don't really quite understand it. So in this kit, actually the book is free. I give this book as a freebie, which is almost, well, it's 89 pages of a lot of details. And so those who are complaining that I don't give everything away for free, well, do you work for free? This book is for free in this kit, and these videos are free too. These are things that you can do yourself without buying from me, and essentially what I'm teaching people is how to do things for themselves. I'm providing parts for people because they've asked for them, and so I don't appreciate those rude people from time to time that want everything for free and don't contribute anything themselves. So anyway, we're going to look at a couple of things here. Again, this book goes over, it's two sections. The first section is the instructions on how to create resonance with two coils, or one coil, one coil or two coils, with two wires connecting each other, or that's chapter 1. Chapter 2 is one wire, where we create resonance and transfer energy through one wire. And then the third chapter is on how to do resonance wirelessly. While you're doing resonance, you're transferring the power wirelessly, is what I should be saying. And all that also in relation to grounding, which in this case is the plate. Now, I don't say anywhere in this book to ground to the earth ground, because it's actually quite dangerous. There's enormous amount of power that you can get from the ground. So I can't do that because I don't want anybody to hurt themselves, and I have to protect people. So those of you who are qualified can understand how to do that. The new Don Smith book is going to get into that in a lot more detail, and it still is a very dangerous thing. So I don't say that anywhere in this book about an earth ground in relation to this kit, because with the connection to the earth ground in the right way, which we go over in the Don Smith book here, then you can create as much power as you could possibly dream of, and beyond that, even with this little kit. So but I will show you here how to do that without the earth ground in a way that just multiplies these particular parts. So we have additional coils here that can be purchased separately as optional, and on the website has the information. So what we're going to do is talk about that, but first of all we're going to start off with some details here. So I have included in the kit also a gate driver. So we're going to not use the gate driver, and we're going to see the difference that the gate driver makes. It's a huge difference. So first of all, before we do that, we'll talk about the frequency generator here. Now this comes either assembled or unassembled, depending on your option. I don't really care for doing the assembly of this. Right now I just do that as a service to help people succeed in this. And this kit is, this little frequency generator kit is really inexpensive. It was to make this kit affordable. But it does have its limitations in that it's very sensitive to get into the resonant point. So if you even touch the capacitor, or this knob here, actually this one is the adjustment. This is the coarse adjustment, this is the fine adjustment. But if you just even touch it or come near it, you have a capacitance coupling with it that can actually increase your output, because you're acting as a ground too. You're contributing electrons to the system, and you're actually affecting the tuning. Anyway, what we're going to do, I don't have it with me, I just gave it to my nephew. Anyway, I have another one that will be available as an option for $30 or $20 more, because this is about $10 to the price of this kit. And we're going to add another one, which I have included in the description of the kit on the website. And it's really a lot better frequency generator than this one. It goes up to 2 megahertz, whereas this one's only supposed to go up to 1, and we're actually pushing it to 1.2 megahertz here in this kit. So this is just an affordable way. So what I'm going to do from now on in the kit is we're going to sell the kit without a frequency generator, and then you can include this as an option for $10 more, and then the other one, which will already be assembled, as another option for $30 more. Now this one to be assembled is another $10 to be assembled, and I partly assemble it just so that you don't get the capacitors backwards, because unfortunately the way this is indicated here is kind of misleading on the way the capacitors are placed. Like you'd think the shady area would be the negative side of the capacitor, but it's actually the positive side. So I don't know. But anyway, this is part of the kit, and what we're going to do is we're going to start off with a regular frequency generator, a more expensive one that has more options, bells and whistles, higher amplitude of voltage, and we're going to look at the kit. It's actually already running right now, I think. Oh no, it's not. I had turned it off. I have to reset it. We'll go over the settings on that. So we're going to have this as an option, assembled or unassembled. We're going to have the next one. The next one I can't show you right now, unfortunately, because I don't have it. I'm waiting for more to come in. Now it gives you a digital readout. You can really fine-tune it a lot easier than this one, and it also is it's got duty cycle, it's got memory settings, it's got a bunch of things on it that are really helpful. A couple more waveforms. This one only has 3. It's got the square wave, which is what you want, the triangle wave, and the sine wave in this one as options. And the other one has more and more features and really fine tuning. So I think most people will want the other one. I'm just trying to make this affordable as possible, and I'm also going to make it so that you don't have to buy the frequency generator if you already have one. There's no point. But nevertheless, you'll still get the the gate driver. And we're going to see in a minute how much difference the gate driver makes to the kit. Alright, so let's go and start off by running this thing. Excuse me. What we're going to do is set up the frequency generator. In this case, we're going to start with a sine wave to show you the difference. And we've already got the oscilloscope hooked up. And I will probably come around and focus in on this so that you can see the details. So we've got the voltage, and we're going to have the peak to peak. So this side right here is the voltage, and this is the peak to peak. And we've got 10 times probe on right now, set at the 100 volt intervals here, divisions. And we're not going to worry about these coils right now because they're going to be after we run this basic experiment here. So let's start off by setting this up. So we're already, we're going to change the amplitude to 20, oops. Okay, so it's 20 volts peak to peak. So it's 10 volts up, 10 volts down. And now we're going to go over to the frequency, and we're going to go up to 1 megahertz, and then we're going to go, and we can already see, so when we're outside of resonance, we're only at 40 volts peak to peak. Now, if I don't have the ground, now where I have this is in the center. I don't have it across the input terminals. I have it, so what we have is a series tank circuit here, resonant circuit. So we have a capacitor going to one end of the coil, and then the other end of the coil coming out to the negative. So positive to the capacitor, the other end of the capacitor, the coil. So we have coil, capacitor in series with each other. And we've got either end connected. Actually, usually I do it the other way around, but that's fine. I usually connect the positive to the coil input and the negative to the other end of the capacitor. So we can just do that switch. Now what I'm going to do is connect the negative of the probe. So the positive of the probe is in the center, and the negative of the probe is on the capacitor, just like the negative of the frequency generator. So you can see we're really low. We're looking at 40 volts peak to peak. Now I can adjust this. So it's actually 36 volts peak to peak, 24.8 volts. So we're going to sweep through, no, we're not going to sweep through, we're going to go into frequency generator, and we're going to start, whoops. Well, actually, we might as well start with, so we're going to see this voltage rise and fall according to, so I'll just tell you the numbers here instead of moving the camera around. So if we look at 300, or sorry, yeah, 300 kilohertz, we can see 400, and we're starting to climb, and then back down. Now I'm not going to bother to sweep through. These are like harmonics that we're going through. So 182 at 600. So that's another close area. If we go to 800, there was one there. Now we're in the sine wave. We're not in the square wave, which is where we want to be, which I'll show you in a minute. So now we're at 101, 1 megahertz, 100,000 kilohertz. Now we're up to 200, 1.2 megahertz. And so now we're climbing a bit higher. So now I'm going to go down a digit and fine tune this. So I'm at 1.17. And I've come to kind of my max there. 1.6. So we're at about 200 volts, peak to peak, 100 volts. So that's without the frequency, or that's with this sine wave, and that's without the gate driver. So now if we go over to a square wave, we've suddenly jumped up to 2.5, or sorry, 250 volts peak to peak. And now we're going to go and adjust the frequency again. And we're pretty much at the same spot. So 250 volts peak to peak. Now we can go back and look at this. Well, first of all, the kit comes with this little LED, like 5, 6 of them. And this helps you to really tune in, because these can take a lot of voltage, these LEDs. Most LEDs can't, this one does, and like usually they'll burn out on you if you have too much voltage on them. This one is really good. It's very sensitive, and it's got a good output. So it's not something that is going to convince people of over unity in itself, because, you know, what does it take to run these LEDs? Not very much. So, you know, when you get these kinds of LEDs, you're going to really see more output on them. But this kit wasn't really to show you over unity as much as it was to show you resonance. Now, we'll show you over unity, but you have to know what you're looking at. So anyway, when we go over from the square wave to the sine wave, let's go back. So if I go between okay, there's the sine wave, and there's the square wave. So you can see a big difference. And see, my LED goes out if I'm in the square wave. Or in the sine wave, it goes out right here, and now it's on, and I can go farther away. So the amount of available flux is less, as you can see, as it corresponds to the oscilloscope. There's a difference. Now, of course, we did adjust the frequency, so there's that too. But you're going to get, what I'm going to go over again is the rate of change, which we've talked about a lot in this book, in the impedance phenomena. The rate of change, as Tesla talked about, is vastly important. So it's not just the frequency in resonance, the rate of change. So if you look at a sine wave, you know, it's a slower rate of change in a sense, whereas a square wave is very abrupt on, very abrupt off. And so without the gate driver, these frequency generators are you're going to see quite a vast difference here in a moment. So can we run, okay, so now we're at the sweet spot. Okay, so the sweet spot again, if we go back to the frequency, alright, so that is the maximum resonance for this coil with this capacitor. So you've got two things that you're tuning, and they're coming together at one point. So you've got your inductor on the one side, and you've got your capacitor, and you're tuning them together, and whatever capacitor inductor you're using, they will have one resonant point of tuning. And when you have other points that are harmonics that will be similar, but this would be the dominant one. This is the fundamental. So we're already there. Can we run now? Is it enough flux to power this light bulb here? Well, I have to be careful not to touch it. That's why it's good to have this stand here. So I'm barely getting anything out of this. So that's without the gate driver. Alright? So that's not very impressive compared to what we'll see in a minute. Now, what we're going to be selling, part of this video, is the new kit, or sorry, not the new kit, the new addition. One of the new additions is going to be these ferrite rods. Now we already sell these with the crystal radio addition to the kit, because you can make this a crystal radio by adding 3 more parts: the earphone, the ferrite rod, and then the crystal diode, and they come separately if you want to buy that option. Now, what we've done here, what we're going to do is provide we're going to provide a rod and some wire. You can wrap the wire and wire tie it. We'll provide the wire ties, and then I figure people will want to save a few dollars and spend a few minutes winding the coil themselves. So what we'll do is we'll provide the wire and the rod on the website shortly. It's not going to be more than like $5 or something like that. Maybe less, $4 or something. Anyway, you can see here the relationship. I can still get, on the outside I can't get anything, but on the inside I can take that flux and pull it in and power this bulb here. Now you can see the voltage going down to 60 volts or 120 peak to peak. And so what we're going to do is increase this. So what's happening right now is this coil has a certain Q factor, quality factor. We talk about this in the book. And so does the capacitor. Now we deliberately made these capacitors, they're only 50 volts rating. And so of course we're above the 50 volts right now. But what's happening is, because we're measuring actually across the capacitor here, we're not measuring across the inductor. If I do that, you'll see this is across the whole, and you can see this is the input voltage, which is again 8 volts. Oh, my amplitude's down, so let's change that back. Whenever you switch to sine wave, it goes to 10 volts. So now it's going to give us a lot more output. So now we're at 252. Let's see if the frequency is at its maximum. So let's talk about the Q factor again. And this capacitor, like I said, is only rated for 50 volts on purpose. Now you might be saying, well, Rick, why did you not give us something better quality? Because I actually want to keep it safe. That's the main objective here, is to learn these things while being safe. So now, if you were to have a better capacitor, which I will be providing, these capacitors here are going to be another option for instead of the really small variable capacitor that we normally provide. You can buy this one, and it's about $10 for these. So we'll make that available on the website too. So there's going to be 2 editions today, and next week there'll be 1 or 2 more. And I'll talk about those in a minute. Half an hour maybe. So I make these capacitors low voltage and low Q. They're still decent capacitors, but they're not meant for, they're deliberately chosen so that you're not going to produce a high output here. Because within this voltage range, you're not going to hurt yourself. Now, you can still get some RF burn. So this is the neon light bulb, 70 volts. So this is where we put the 1 wire. And so if you were to hold this in a way like this, you could burn yourself, you know, in relation to the ground plate, which is really not the objective of this video, but anyway, we go over all that in the book, in the kit. So we keep this at a low value. So the Q factor is really the amplifying, multiplying factor in resonance. So as we multiply the output, as you can see here, in this case in a series arrangement, we have a voltage increase, which is really almost the only focus of this book. We do a series and a parallel arrangement, but this gate driver does not allow for a parallel. So for those of you who are wanting to do the resistor test, which we'll talk about in a minute, you can't do this test with the gate driver. The gate driver will not allow for a parallel arrangement, but you can do a series and a parallel. You can add another capacitor, and then you could do that test. So we show that in the book as well. And I'll talk about that. Well, I should just mention that when you do that test, no, I'll mention that later on because it's too confusing. We're talking about the Q factor and multiplying factor. So now, so when you consider the Q factor of a coil, we have an LCR meter that measures the inductance, capacitance, and resistance of a particular object. So a coil by itself, you can measure those, and the capacitor by itself you could measure, or you could actually measure them together. In this case we have a load, a resistor, or a capacitor, and an inductor. And if we measure it, actually haven't done this in a while, I'm not even sure what the values are on this. If I could actually do this. So this will actually tell you the Q factor at some preset frequencies. So we're looking at, in this case, it's showing the microhenries to be 157.8 at 1 kilohertz. And changing the kilohertz to 10 kilohertz or 100 kilohertz doesn't change the inductance that much. So it's still 157.8 at 100 kilohertz, which is what this meter goes up to. Now if I go and change the LCR button and start looking at the capacitance, we see it's 16 nanofarads. And then it gives me some resistance values as well. So if we go back to the inductance measuring, it's showing right now that it's at 93Q, 93.4. So like I said, this is around 100 times this kit when we consider, and that's with the LED across it as well. So at this particular frequency, the Q factor is 90.7. Now as we go up higher in frequency, the Q factor is going to raise to some extent, depending on the coil's diameter and various other factors. So anyway, that's your LCR meter. If you want to get into building your own coils and the Don Smith systems, you have to have an LCR meter. This is not really sufficient meter. You have to have a more expensive meter to determine the frequencies, the factors and the inductance at higher frequency than 100 kilohertz. So that's, I mean, you can work it out with the oscilloscope as well and figure out your values, but to design a proper coil takes either the simulation software or time to tune things. But this will give you the general ballpark anyway to work with, and then you can do the fine tunings. So this is about $120 on eBay. It's a Japanese product, and it works really well. So the Q factor normally is considered the, if you look at your electronics books, you'll see they focus on tuning into radio stations, and when you get, you know, you're talking about your bandwidth and you're tuning into, you're talking about the width of the Q in relation to tuning into a specific station. So as you turn into that particular station, you're tuning into the resonance of each particular station. So that's what they focus on in the books. But really what's actually happening is, as we can see, with our input voltage only being, let's go back to that now and measure. We can see the input voltage is 14 volts, or 28 to 34 volts peak to peak. So there's already somewhat of a gain from the input. This is only 20 volts peak to peak. So we're already gaining, so some of the energy is already going back into the system, because if we go out of resonance, right, then we should lose some of that. So now we're only at 10 or 12 volts and 26 volts peak to peak. So it's gone down. So we'll go back up, and in this case, we're at 1.17 megahertz on this. So again, that's without the gate driver, and we're going to add that in a minute. So the Q factor here is giving us potentially at least 93 times the energy if we have a suitable gate driver, according to the LCR meter. Now the squareness of the pulse will increase the output even more. So what we have here is 246 volts peak to peak. You know, so that's showing us 10 times of a gain here in resonance. So it's a multiplying factor. I have 10 times more voltage with the same amount of amperage. Now the amperage will go up too a little bit, but generally speaking, you consider a series resonance circuit where you're gaining in voltage, you're multiplying the voltage while the amperage remains the same. And now we do find the amperage going up a little bit. And in a parallel, where the capacitor is across the inductor, we have an amperage gain. So the voltage remains the same. It does go up a little bit, but then the amperage increases. And the Q factor is how much of that it increases. So in this case, this coil at the frequency of the capacitors that we're using, with the capacitors we're using to keep it within the about 1 megahertz range, we're getting a Q factor of potentially 100 times that this coil can produce. We can change frequencies and we can get up and get more out of it than that, but there is a limit to it. Anyway, with this capacitor we're really dampened, as you can see, and without the gate driver. So nevertheless, for the amount of energy in, I can go all around here. So almost probably 70% or so of the area around this whole, like the whole area, not just on this plane, but all around. So you've got all this area right here, 360 all the way around, and then all this area and all this area. So I could put about 100 coils around this and collect about the equivalent of what this is putting out. Well, that's not correct. What it's taking to run this coil, I can have 100 coils around here collecting the energy that it took to run this coil times 100. So that's not including the energy that's being multiplied in the coils themselves, because each one of these coils has the same gain in resonance. So what's happening here is, this is a very easy way to demonstrate. You're getting more output than input, and we can easily actually use one or a few of these coils to actually provide the power to run the frequency generator, and then you can have all the rest. So there's your over unity, the way some people define it. Now, what's happening here? Let's talk about that a little bit, the magnetic streams. So what's happening here, the waves that are coming out of here, which are normally disregarded except for radio transmission and a few other things, like your microwaves cooking your food, and your radar guns and so forth. What's normally in regular electronics systems, this whole magnetic byproduct, which is caused by the electron spin. So every time an electron is excited, it spins, giving off a magnetic and electric. There's always the two. And that's where you can take this meter and measure, determine the voltage at the distance with the square laws. This one's very sensitive, so you have to get the right position. You can determine the actual voltage on a high output system by the Gauss, and there's a whole simple formula as to what 1 Gauss equals, or 1 milligauss equals 100 volts, I believe. And so you can determine the actual voltage by the distance that you are from the transmitter without having to use the right voltage device, because voltmeter. If you have a meter that is like a regular meter, I had one out here somewhere, that won't necessarily be able to read the high frequency, and it could ruin the meter very easily. And obviously if it's a high voltage meter, not a high voltage meter, it will damage the meter. So that's what Don Smith talks about using, especially on the higher power systems. So anyway, if we have, say, a half a watt or a quarter of a watt running this input, and then we're running each one of these coils at a quarter watt output, and there's 100 of them, then what do we got there, guys? I mean, this is not, this is really a lot of output, and I've just really dumbed this down so that it's safe. But this can demonstrate this even with 2 coils. Generally, that's why most people bought 3 coils when they bought this kit, because then they could see more than just 2 coils, because it's helpful to see. So we talk about this book, I go over the MIT experiment where they supposedly act like they've discovered something that Tesla showed this 100 years ago, but they act like, oh hey guys, we're 10 meters away here and we've got 40% of the energy, I believe it was, received in this coil. And of course they're giving a misrepresentation of the real potential available, because if they had another coil over here that far away, they would get another 40% over here. And then they had another one over here, and they could again have, within that distance, they could have at least 100 coils as well, all receiving the same amount. So what's happening here is the magnetic streams, or waves in this case, are being broadcast, if you will, through, because of the electrons that are being spun in the, well in this case it's above 20 kilohertz, so the energy at resonance, the high frequency above 20 kilohertz is on the outside of the wire, is traveling, if you will. And so what's happening is, as these electrons are spinning, they're giving off both electrical impulse on the one hand. First they're giving off a magnetic impulse, and then they're giving off an electrical impulse out of phase from each other. Every time there's this pulse here. So there's 1,170,000 times per second this is happening. And what's happening is these magnetic streams are going out, right? This is where the square laws come into play. So as they go out, at the square of the distance, the magnetic waves are going out, right? They're not diminishing. They're just going out, and they will go out throughout the universe if they're not deflected or absorbed or what have you. So what's happening is they go out like this. So the closer you get, the more magnetic waves you're collecting, right? That's why it'll be more intense here. It's not that the waves are weaker out here, it's just that you're getting less of them. This is very important to understand. It's a very basic thing people don't get. So if you're close, like I said, if you're in this proximity here, you can have quite a bit of coils all around here. And we already talked about in the last video the repeater effect, where if I have one coil here and I have another one here, this coil becomes not only a receiver but a broadcaster as well. And so anyway, the point is that I can collect enough right around here of the magnetic streams to influence in this receiver coil the same kind of action. The same, because this is tuned to that frequency, it can receive these magnetic streams in a way that it will then produce the same effect in here. So it takes the magnetic streams now, or waves, and converts them to, again, in this case, it starts off with electrical impulse and then followed by magnetic impulse. So it takes the magnetic waves, produces electric, and then magnetic. And then so the magnetic streams then go out, which then can go back to this. So if I have enough of these all around, you'll see my amperage to run this coil go down and down and down, and it can get into the negative. And it could actually damage the equipment if you're not careful. And so I showed that with the bigger coil at the last meeting, and maybe we'll do that today. So now, so what I'm trying to get at though is that the few magnetic waves that are coming off of here are enough to produce the amount of power that it would normally take to run this system, right? If we're looking at 20 milliamps, or we're going to go up to a lot higher than that when we show that the gate driver and other details in a minute. Although we'll be at 9 volts instead of this being 20 volts. We're going to only be at 9 volts. So we'll go over that in a minute, but I just want to stress that point where one of these coils can receive enough energy from this far of a distance to actually power what is taking to drive the transmitter. So there's your unity, if you will, but now I add many more coils, and I've just increased all that, and then I can actually add more around this coil in a way that can actually benefit from that radiation that's going off here. And that's one of the main things that Don Smith talked about, in which we really stress in this new book here that is now in print. I'm just waiting for my copies to come right now. So this is with a low Q, guys. This is really low Q. If I have a higher Q, we're going to use this capacitor with this big coil later on in this video, and you're going to see even more of a gain. So let's look at can this run any of these bulbs? We already saw that it can't, but for now I'll just hook it here, and you see now these ones have the better capacitor and the variable capacitor. Now the thing about it is, so you can see it just barely, it is coming on if we get close enough. Now the other thing is, if you have a very strong resonant coil here, you'll still be able to power another coil that is out of tune with it. It's just not going to give you as good results. So now what we're going to do is disconnect the frequency generator, and now I'm going to hook it into the gate driver. Now, hooking up the oscilloscope is giving a ground in which allows you to have the benefits of having the ground in the system. Some of the benefits. Okay, so now I hooked that up wrong. The red wire goes to the black wire. And the grounds are going to be connected together. And the red one is going to go to the input of the gate driver. So without even turning the gate driver on, which is interesting, I'm not even powering the gate driver and it's still going through it enough to give us 86 volts peak to peak. Now what we're going to do is turn on, we're going to power the frequency itself. Oh, before we do that, we want to turn down the amplitude of this. It only needs to be at 5 volts, which is, I have 10 volts peak to peak here. Because this is a logic input, it's not needing, so this is really not taking very much energy at all, and it's very easy, as one of my students has shown, that you can take one of these coils and power the frequency itself very easily. But the gate driver is an amplifier, and in this case we're going to run this. Now we can see that it's putting out quite a bit more. Now we are at 100 volt divisions and I can't even see the end of it. So judging by this, that's 1, 2, 3, 4, 5, 6, 7, 800 volts divisions, and we're going to go up. Okay, let's go. So there's 800, 900, 1000, 1100, 1200 volts peak to peak. Now of course I'm pushing this quite a bit higher in power input. It's 0.139 milliamps at 9 volts though. So that's quite a bit more power. So a couple of things to notice. And we can change the, I'll change that in a minute to the other probe that's, this is a 10 times probe, that's a 1,000 times probe. We're going to look at when we go to this one, because we're going to get to really high voltage, a lot higher voltages. But now you can see we're powering up all these, and this is where we'll get into showing. Now I can power on the external side here. So this is actually still, oh, what we have to do now is retune this. So we're not even tuned. This is very sensitive right now. Alright, so we're going to look at this. Okay, so that's the sweet spot. And it's drawing quite a bit more amperage. Now, of course, I have to retune all these if I'm going to make such changes. You can see these lights are on pretty bright. Oops. Some of these bulbs have been greatly abused. Like this one is, oh wait, this one is clearly damaged. So the closer I get, now these are all going to be influenced by how close they are to the transmitter. So what I call a near-near field is, once you cross the near-near field, you're gonna affect the transmitter mostly negatively, like you're going to put it out of tune. So we can see this. If I can take the waves that are coming off of this in this, at this distance, I'm collecting it for free. So anything outside of this field, or this area, is not going to influence this one's all crooked. Well, let's use another one. Now again, this will depend on the size of the wire. That one's a pretty big wire. It's not really meant for this setup, it's for the bigger ones. So way out here, I'm getting decent response without affecting. You can see the waveform isn't changing, and I'm still getting action here, or around on the outside here. So if I go in, guess what happens? Now I put everything out of tune when I do that. But I also bring down the power. Like this is going down now to 38 milliamps. Right? The voltage has gone down. So this is good and bad. Here's another one. But the point is, on the outside here, I can add as many as I want all around here. Right? And you can put them side by side, more or less, depending on what you're doing. So these rods are going to give you the chance to do this multiplying factor in an affordable way, and but they're different than these coils because the rods more absorb the flux than transmit it, whereas these not only absorb, or they don't absorb it, they're influenced, and the magnetic streams still go on beyond them, the original transmitting ones, and then they transmit themselves. So they are more important than these rods. But if you want easy output, it's still high frequency, so these bulbs can deal with the high frequency, whereas other loads can't. Now you can also do a capacitor, and what we have is the capacitor here. I think I showed that in the last video, where we're charging a capacitor with one wire to ground, this way, Avermenko plug situation there. So anyway, we can still utilize this, and we can run all these loads. So this is just now more pronounced. So let's try. It's more output because there's more input. So it's still the same kind of ratio here, although we've increased the power. So if we drop it down to the same input, we still are of a much higher gain. So I'm getting quite a bit more than I would get if I didn't have a gate driver. Now I can go up on this amplitude. It shouldn't really make much of a difference. Let's just see that for a minute here. So going up, so I can go all the way down to 6 volts peak to peak, and it still hasn't changed anything because we're not really producing, this isn't really taking any power. This is just sending a digital signal, right? And then this is one that's powering. So if we change this voltage now, we should see it rise a bit more, but we're not in the safe operating area. So 9 volts just happens to be around the limit of this gate driver. So at 1.2 megahertz, 9 volts is really the limit, the safe operating area. Otherwise this thing's going to start getting hot. So if we're going to go down to a lower frequency with this big coil, and then you will see that we can push the voltage higher. So let's go back to, so that was another 100 volts, no, actually both sides are going, so another 200 volts when we went up to 11. So now it's really putting out. These are really bright, it's blinding. But we don't want to keep it there because it's really pushing this thing. I don't feel it getting hot at this point, but it is really pushing it too high. So, well, we can go with that and then see this again. See, again, we're bringing it down because this is absorbing and changing the tuning. So we're going to change the tuning of all those. Now, this one's not in the path of it, so it wasn't on. So depending on the wire gauge, you'll have, the load you're running. See, this one has a thinner gauge wire. The other one is pretty thick. I think the other one's 23 gauge, or actually, the other one's 18 gauge. So this is the receiver coil now. So you can see I don't think it's affecting. There's a very strong effect here. Now this is probably receiving the original flux. So if we go over to this one, maybe, no, it's still, see, it's affecting, it's putting it out of tune. So all these things have to be tuned. When you're trying to run a load off of the receiver coil, then this is not the way to do it, actually. So you really, if you want to do a Don Smith system, when people are trying to do that, they don't understand, they're detuning it. So these loads are actually detuning the process. So you want actually an isolated system. And that's again what we get into in the book. And that's one of the major points people don't get, because they don't know by experience. This is why this kit gives you the ability to do it very easily and experiment, because you can see the relationships a lot easier than if you're working with really high voltage, which is dangerous. And why would you want to work with thousands of volts? I mean, we're already at over 1,000 volts with this already. But you don't want to be up there, 12,000 volts. With your input driver being 1,000 or 9,000 volts into your driver, it's very dangerous. So this is the way of doing it. It's not so dangerous. So anyway, as we load this down, of course, the input drops. So that's this kit. Now what we're going to do is go into the bigger one. Well, what we'll do is start off by changing the probe out, getting it set up. We can look at the probe now. And see, this is a cheap one, and so it's kind of finicky. So we're going to look at this. See if it works. Now I've got to change the probe to 1,000 times. So here we have the proper probe here. This is a 1,000 times probe, and now we can see we're at the 500 volt setting here, and I will come over and bring the camera there so you can see 500 volts on there. .500 volts peak to peak, actually 1,300 volts peak to peak. Let me just bring that down slightly. Alright, so now we have I'm going to turn up the gate driver voltage, and we can see it go up, and it tops off at 11 volts input is the maximum this gate driver is going to put out. So we're at 1,580 volts that this thing is putting out, and that's with these caps that are only 50 volt caps. So we don't really want to stay at that, it's going to get too hot. So we're going to go back down to the safe operating area. And so we can see 1,300 volts, 1.3 kilovolts. So we're going to, I'll just bring the camera back into position. We've seen all these things already. If I come in there, I'm not changing it too much. All this area is the free area. Now you can see, now again, some of these things, as I touch the coil here, I change things quite dramatically. So my input is only 21 milliamps when I'm shorting it all out. So that's all the gate driver wants to take to run itself, which is, but now it's drawing quite a bit more. Now if we did a parallel, it would be different. It would draw less, and parallel is the way to go on normal. But right now I'm just showing the voltage and that. So again, we can run a load within these. More or less. Alright, so now what we want to do is switch over. We'll turn this off. We'll change this frequency to 180 kilohertz. No megahertz anymore. 183, I believe it was. And now we're going to remove this coil. In fact, all these coils. Because we are going to run this big coil so now we're going to drive this. I guess we might as well go through the stages again. Well, I'll just go straight to the gate driver. There's no point in going through it all over again. Okay, so we have, this is the transmitting coil. This is the capacitor. It's already, this is a variable capacitor. This is like a $300 capacitor. And this is in the all the way down to 80 picofarads to all the way up to 1300 or 1100 around. So now what we're going to do is connect this up again, the oscilloscope, because this one's going to be really high. And we're going to start at a lower voltage here because it's going to be crazy high. I'm on the wrong spot. This probe has to be connected to here. I wasn't on it. Yeah, there we go. Looking at the wrong connection. So now we will adjust the frequency accordingly. We're going to have to go. Alright, so we're at 3,700 volts. So we can go up to 18 is the maximum this gate driver can do. And the amplitude doesn't make a difference here until we get down to like 6. If we go at 5, there's nothing, which is really only 2. So this is like 3 volts input into the gate driver. The gate driver itself is putting out, it's still not even that hot. So now, this is a very blinding it's going to blow out if I do that. So we have 3,000, well 4,000 volts. Now if I tune this cap just right, when I touched it I burned myself. So you can see it's very fine tuning here. I usually have a wooden tuning mechanism here. I just lost it. great. Something is not hooked up anymore. Sometimes, yeah, frequency generator turns itself off sometimes. Anyway, what I'm saying is, I could tune this here and there. And get it better. Oops. That's not the frequency. So right now we're almost at 4,000 volts. I can get this up to 5,000 if I get the right numbers. We're at 189. So when I tune it down to 183 and I tune the cap to that, that's where it wants to be. Now what I have to do when I'm doing all this to show is I've had to change out the capacitors that we had there, which are 100 picofarads, to 5,000 picofarads or 5 nanofarads. And these ones are 1600 volt, so they're more suitable. So now this cap is at a lower frequency in this coil combination, but they're at the resonant frequency of this particular combination, or so that these two coils are tuned together. This is what I show at the meeting. Now, what I show at the meeting, which I'm not going to show here, I have to leave something for you guys to come to see. At the other meeting I had, I don't know, 15 or 20 coils just on an angle like this, right? And then I placed them in such an arrangement. Now in this case that's not the right coil or the cap, so I'd have to put one of these in here. But what I did was I set it up over the lunchtime and I just got the right combination so that it was in a sympathetic resonance arrangement. Now I don't have time. Well, you can see that this becomes like a repeater coil. So let me see if that increases. Yeah. So the way it is, without doing any tuning here, so this amplifies the signal out. So it's a repeater coil. So I had this all set up in a way where I had a whole bunch of these coils all around, right? All lined up. And I had like 3 or 4 layers. And what ended up happening was, as I added them, my input went down to like next to nothing. Now in this case I don't have that arrangement. I'm not showing it here, but I could put as many of these ferrite rods as I wanted in there. There was such a strong bond, it's sympathetic resonance in this case, between the transmitter and the receiver, that I could put all these ferrite rods in here in the pot and it wasn't affecting the power. It was actually bringing the amperage down. It went down to 20 because that's all that power supply could show, the lowest I think on it. I had brought it down here to below 0 before, but I'm not going to show that right now. But anyway, so what I could do is add all these extra loads on it and it wasn't affecting, it wasn't detuning it. It was a very strong bond. It was a lock, you know. Then it was a phase conjugate mirror experience where the energy was going out, coming back in, if you will. But it's not really that it was going out and coming back in. Ouch, I just burned myself there. This is the very hot spot. This is the high voltage point right here, and this is the high voltage wire. Usually I hook it around the other way. That's probably why I got the lower voltage. Yeah. Anyway, actually no, it's fine. So what you find is you can see that there's different levels here of where it responds. So there's a high and a low point. So this is what would be considered the bottom of the coil. It's kind of upside down on a Tesla coil, and this is the top end. Now there's a lot of power here, so you can see just bringing it around anywhere around this wire here, not so much this wire, but there is still activity on the so this is the high side. So everywhere around here, this is a neon bulb, it's lighting up. I can turn out some lights and show this. So you can see all around here, it's all the electrons here are all in resonance. Like Don Smith talks about all the ping pong balls in a room lighting up, or sorry, lighting up, being aligned, and now, so this whole area is just, I'm just touching it, which I'm providing electrons from my own body by doing this, which is not healthy to do. You're robbing yourself of your electrons. But anyway, especially right here, this is where you'll burn yourself. You can see, and I'll really detune it while I'm doing that. You're not supposed to do anything on the transmitter. I'm just showing you some things. So anywhere I touch, even the gate driver itself is going to produce, anywhere that I touch anything, even the ground here is still lighting up because I am receiving right now. So look, here's a plate that's just sitting here by itself. Everything's electrified. If I do it real good, I can even electrify the wood. Or a plastic. Well, in this case, I don't even have to touch it, and it's coming on. So if I touch anything, so you can see here when I touch this, because this is receiving, this is tuned. I don't even have a load on it, so it's the repeater coil by itself. But I could put a load on it and still it'd be tuned enough. So this one is not tuned, so it's not coming on. Anyway, you can see from the bottom, actually this is the high side, sorry, forget what I said earlier. The bottom, it goes out. So what's happening is the magnetic flux is building up with each layer here. And so by the time it gets to the top, there's a lot. So this is the high side. This is where you'd put your L2 around that side of the coil if you were going to pull off of it. So anyway, that's that. We can look at some of these here. So just coming down. So depending on so this is obviously more than 1 watt worth of energy, and of course you can power many of these, but it gives you a chance to really see something that you can say, okay, well that's real power there. But what you really want to do is, if you get into the ground situation, you can power, really, with this coil here, you could definitely power whatever you wanted to ever power. Because if you've got 30 or 3,000 or 4,000 volts, depending on how we tune it, see, it's kind of detuned itself in relation to these coils a bit. So volts and amps can be equal. And when you understand the whole picture here, I'm only showing the first steps, because without that you can't go on to the next steps, right? I want to show those steps and make that clear to everybody. But once you get past that point, then you can not load directly. You don't want to load like we're doing here, load directly off of the coils. You have to go to another stage. There's, in the book I get into 5 different stages. And so this is only stage, basically 1, kind of stage 2. And there's 3 more stages to do the full process. And if you get into the full process, then a coil like this could power, your amps can equal volts. So whatever, if you have a load big enough that could handle that, you could power such a load. And that's not even including adding more to it. So in other words, we still have all this flux that is going to be radiated out that could be collected, and you could do the whole thing over again. So in this case, we have, make sure this is not hot. So we could have like 1 watt here powering, 1 watt, and we could have 3,000, 4,000 volts at that much amperage if we wanted to. The amperage doesn't appear until you have the load. And when I say that, you have to have a suitable ground system in order to realize that kind of amperage, because you have to supply the electrons to the system. And you have to do it the right way, which is what people misunderstand. So that's the major point of this book. The 2 points being the magnetic wasted energy normally that we're utilizing, and then of course the second point being the grounding and its relation to the electron spin and so forth. So in this case we have a thinner wire, more turns, so it's a lot easier for this bulb to respond to this kind of, it's not going to affect it. But in this case we're bringing down now the input and we're detuning it. So again, what we're getting into is the main point that I'm trying to show here is that you have an increase from your input. So if we have only 16 volts here in this case, and we've got, almost 4,000 volts increased, then there's a big gain there. Now this is a nice coil in that it's squarish in the sense that, or cube, so your diameter and your length are more or less equal, and that's nice to have. You could get a lot different results by having a lot less wire here. There's a lot of inductance. Anyway, it's just showing you something. I just kind of threw that together one day, and it worked out to be one of the numbers I was after. So again, the main point is that, well, the first point being that you have to tune a coil with a capacitor to get the resonance. You have to tune the frequency to a coil and capacitor set, and we've done that here. These are the numbers, and then there's a gain. So in this case, this coil is capable of even about 1,000 Q at a reasonable frequency. So we can see 1,000 times more energy in a very simple system like this. And that's not even showing you a ground connection and all that. That's where the real power comes in. So now you're not just getting 1,000 times more, but you're actually getting the amperage increased as well. So you can get right now, so say you could get, if you get 5,000 volts at 20 milliamps, in this case we're at 200 milliamps, but if we had 5,000 volts at 20 milliamps, and there's only 20 milliamps input at 5 volts, say, we were running it, I was doing that before, at a different frequency and a different arrangement here. The reason why I had to choose the frequency that I have right now is in order to make these in tune with them. So this is not the ideal frequency for this particular coil, but it was the only thing I could do to match with these coils, because I want to make this relevant. I show this at my meetings, to make this relevant to the to these coils so that they're matched. But when I tune this in a more ideal, now the reason why is because it's hard to get capacitors. You can't get tunable capacitors at this high. They're all in the picofarads, and this is 5,000 picofarads. You can't really find very many capacitors that are variable at that rate. So I picked, these 5 nanofarads, and then I tuned this accordingly. So, but let's just say that this is capable, which I've already done, of running 5,000 volts at 5 volt input to 5,000 at the same, well, a little bit more amperage. And again, if I have the ground connection, I can have voltage equal amperage. But in this case, if we're just going to look at the basics, what people can see, I can make a coil like that, have 1,000 Q, and you can make them with 3,000 Q or whatever. These big diameter coils really can do a lot. That's why this is capable more than this kit. You gotta watch. I'm pushing it to the limit of that gate driver. Anyway, the point is that I wanted to show essentially a practical demonstration of resonance. I wanted to show the tuning differences between the coils, different frequencies. So we've seen this run at 1.2 megahertz around, We've seen it with the sine wave, the square wave, and with and without the gate driver, the differences. And now we can see the bigger coil, and these tuned to a different frequency, quite a bit lower. And you know, so if we increase the frequency with the right settings, then we'll get a whole lot more gain than even the 1,000 times that I'm talking about. So, I mean, who really needs more than 10 times, I mean, even 2 times the gain? Like with my motor set, which, you know, the basic level of the motor systems, you have 1 input for 2 outputs. And then now we've been showing 3 outputs and 4 outputs, so 4 times the output. And now we're going to be showing the next addition, besides these coils and some hydrogen system, will be a coil for the motor, and then there'll be also a Benitez system. So we're going to integrate all these together, so you can do with the motor kit the same things at the same time without even affecting the motor or actually enhancing the motor. You can enhance it. And then, of course, will lead to the 3rd stage process, which is very similar to this, but a lot more sensitive than the motors normally run at, or tuning that, being very careful. We have to work all that out still. But anyway, this gives you an idea of how to tune things, the various parts that you'd use, and then it shows you how you can get more gain. And then, so the very bare bones of it is you have a high Q system, and you can pull off of it, but you can see this is not the way to do it off of the transmitter coil, unless, as I talked about, you're in a sympathetic resonance situation where you are your receiver coils are producing enough energy and sending it back into the input. And that can also increase the output as they, like those bridges that collapsed, they get more and more collective resonance or collective output, and could vibrate to destruction, like on that bridge. So in this case, if we do that, then I can load down the transmitter like I did there, and it will only bring the input down, and then you can get no power loss at all, and then just keep adding to it. So that's not something that Don really talked about in the book. That's something that I focused on in the first book here, the Resonance book. And now I've shown you what you can do with the kit to try and accomplish that, which I showed at the last meeting. And we were going to do something else, but then when I locked into that at lunchtime, I was like, oh, okay, this is what we got to show now, because I just so happened to get it, you know, only had a short time to eat lunch and set it up. And then when I locked in onto that, which I wasn't planning on doing, I said, okay, this is what we got to show, because that is like really important. That's not something I only talked about. I never demonstrated that before, except for demonstrating what I call my 3rd stage process in the motors, where that can happen, where everything is charging. That's where Cron says, now you can take away the input. You know, everything is above, or it's at 0, because if it's too high, then it can destroy itself. So, anyway, that is what I wanted to talk about. So what we're going to do with the additional kits is we're going to have another coil that's going to be based on this same tube here without a base on it, and we're going to use that for the motor system. So that will be an addition coming shortly. And like I said, we'll have a new frequency generator option, and then we'll also have, which we already have, these coils, or these rotors, sorry, these rods with wire that you can wind yourself, and then you can do some of these experiments if you already have the kit. And these bulbs, I'm not sure if I'll start selling them or not, but they can be ordered on eBay, and these can be either 3 or 10 watts, I believe. I think these ones are these might be the 10 watt ones. Or you can use these modules as well. These are the 10 ones. Now the difference, oh, hooked into the wrong wire. The difference between, these bulbs are really good because they have capacitors and bridge rectifiers in them already, and they work okay with high frequency. They're not really meant for high frequency, so that's where your limitation is. If you're using diodes, somebody said on YouTube the other day that they see, this is only getting 1/2 of the sine wave. So if you were to have a bridge on there and a capacitor, you get a lot more. Now I can't do this too much, otherwise it will blow out. Here's the 100 watt one. I don't think this, well, yeah, it works a little bit. I really need a different different one. This is not the right voltage though. So you can see this has got a bigger wire, so it's going to be brighter. So anyway, that's without doing what you're supposed to do. That's just showing you some real basics, and then as you add and learn the ground situation, then you can get unlimited power. So yeah, so that's what I wanted to show. Again, oh, we were going to talk about measuring the voltage across resistors. These are 1 ohm resistors that I provide with the kit. Now, I was saying earlier, you cannot use the gate driver and do this test. I say that in the book because this is requiring a parallel, because we're looking at the amperage side of things when we're doing this test. So what one resistor, I'll just briefly describe it. So one resistor is in series with the input. So you're measuring the voltage across the 1 ohm resistor. You're doing the basic calculation of the amperage. When you have the voltage and the resistance, you can determine the amperage and the wattage that is going into the circuit. So you can't really do that unless the two resistors are in series with each other and you're connecting the negative of the probe. If you're using 2 probes, you'd have to have one probe here and one there, and then the negative, the ground, in the center. Otherwise, if you're using 2 grounds at different points, you're shorting things out. But you can't do this test with this kit with the gate driver, because the gate driver won't allow the parallel tank circuit. Now you can run another capacitor in series and then do it, but it's not the actual test that I would recommend. Now what you can do is one at a time. You measure this. Actually, the way we do it, we have an extra capacitor in series with the parallel tank. So it becomes like a series parallel arrangement, if you will. Anyway, when we can measure one resistor at a time, or if you do this where you arrange it where the two are in series, then you got the coil across also connected to that point, and the capacitor, well, the capacitor is on this side of the resistor. This is for people who bought the kit, so it's not for people who don't. They're not going to understand what I'm saying here, but if you have the kit, you will understand what I'm talking about. So anyway, the idea is that you measure the voltage across the input resistor, and then you can compare that with the the voltage across the same resistor within the tank circuit. So this is the circulating current, this is the input current, and you can see the gain there directly. Now this is a real load, now this is a resistor, and it may not be producing anything of value, but it is a resistance. Now in this case it becomes a negative resistor. This would be the shunt resistor, if you will, in Don Smith systems that he talks about. But the point is the voltage is higher, at least double the voltage of this. And of course so the circulating voltage is higher, and it is the circulating current in this case is higher than the input current. So there is something that is so basic when it comes to inductors. And if you study Faraday's law, which you do in basic electrodynamics, and any kind of electronics course is going to teach you this, or it should, and you get into resonance, you can see within every textbook that there's a gain. So either an amperage or a voltage gain. So that's the first thing. So that right there is the most basic thing of showing like an over-unity system. Now people want a feedback system in their definition of over-unity, but the point is the basic idea is more output than what you had to supply as an input. And it's very easy to see that, and it's really by definition of the nature of the definition of Q that's more than 1 is just that, which is very easy to get a Q factor higher than 1, the quality factor. So right there, it's absurd to say, it's highly ignorant to say there's no such thing as over-unity. Now in the book, Don Smith talks about really anything above the ambient. So if you think of this grounding plate, or the actual earth ground, there's your ambient, your zero base point. So anything above that is that you can tap into is free energy. So all of our electrical devices are, in a sense, that. It's just that we don't recognize it, we don't use it appropriately, we waste more of the energy than we need to. And so anything is over unity that is above ambient, which is something that it's hard to come to grips with, but it's true. So that the point is, I'm showing you some different examples of how you get quite high output, and that's not even getting into the whole ground system, as I said. So, you know, that's the objective here, is to show that, and then secondly, introduce these parts that will be available online now, and then I'll have a link on the page where you order the kits for the actual link to the kit, to these parts. And then we'll have, you know, the different frequency generator option, and then the new coils for the motor, or additional coils, and then we'll have this hydrogen thing, just a little tiny thing, and I'll do a demonstration on that when I'm ready to make that available. So a lot more goodies coming, and I hope that helps. And for those who are complaining that I'm selling something, well, if I didn't, people would yell at me even more for not selling something, and I'm just trying to provide a service, and I do have the right to earn a living from this. I'm not making any profit from these things. I'm just making a basic living. So, you know, people who say, I had this YouTube comment by a rude individual who started out asking for help, and then when he saw that I'm selling this for $120, this is a color book, a lot of color illustrations. It took blood, sweat, and tears to do this book, and it cost quite a bit to print this book. So no, I'm not going to make a free PDF. There already is free PDFs that are enough for anybody to figure out. For those who wanted my contribution, the enhancements I give to this book, it's worth $120. And you know, I calculated how much it took me to do this book, all my years of working on this stuff, and the cost of producing it, providing customer assistance, and that's the price I came up with. And if you don't like it, go to another channel. Don't bother watching my videos then. Anyway, for most of you, I really appreciate the support, and I'm going to do another book that's far more important than this book, that will touch on energy, and there'll be some new things in there, but it will be about the problem that I addressed in this introduction, which is kind of what I said in the last video, that I touch on the mental obstruction, or the things that get in the way of succeeding, the prejudice and the bias and associated problems that hinder you from succeeding in doing this kind of research, and also in learning in general. And so I want to do a book the next year on this subject, and go through the whole physical and metaphysical aspects of life. So I'll probably do another video on that, maybe even today, talking about that. But I don't ever ask for support, but what I may do is, I get support by people buying products, so I may do a book if people want to buy it in advance, that helps me do that work, you know, rather than taking, I don't really get donations from people, but if I get pre-sale, that really helps me out. Like, I really appreciate those who have bought the book before I got it in hand, because it really made it justifiable. Otherwise, I really couldn't afford to take it off the time to do that if I didn't have the sales on it. So I'll probably do that with the next coming book here. But anyway, these parts help. If you buy these parts, it helps me to provide more, and I also help people through email and on the phone, people who buy these parts, I take time. Sometimes I get to spend a whole day with somebody on the phone. So I, put a lot into this, and I'm very rewarded by that. It's very rewarding to help people. So I appreciate the support, and for you watching the video, and give me a like if you like it, and let me know. So thanks for watching.